In this video, we're going to try to understand and predict the way that LeChatelier is going to change the equilibrium in any particular kind of equation for any particular substance that will include temperature changes. We'll be covering anything that has to do with a pressure change and anything that has to do with change in concentration. So stop the video now and write down this entire page because you will want all of this stuff. Okay, welcome back. On this page, you are also going to want to stop and you're going to want to copy down the information here. This will tell you where to get the handout that we're getting the problems from, and it will also give you the format that we use that you're going to see in the next part of the video that will give you how to trace the logic that will help you get to the correct answer every time. Now you can either copy down the website addresses directly for the URLs to get to these two documents. One of these is this one up here is the sheet that we have the problems on, and this guy here is the sheet that we're going to be doing the logic on. And after you copied this down, you can restart the video. Just a moment, you want to also look at possibly getting those things this way. Down here is showing you how to get to the same places, only you don't have to put in a web address other than getting to mrwiggerside.com/cam, which is this guy. So go ahead and copy everything down and stop the recording. Now we're going to go through several of the problems on that equilibrium problems from the Zumdahl textbook, which I have here. And you're going to see the problem number 33, A, B, and C. If you would like to stop the video and copy these down right now, that might be helpful for you. All right, let's continue. Now, first thing off, before we ever do anything, we want to find out exactly what the stress is. And as I read the problem, the additional SO2 is added to the system. That means we're adding SO2. So the logic is that LeChat wants to do the opposite. So instead of adding, he wants to take away SO2. And the way he does a takeaway, the takeaway is always going to move the equilibrium to the opposite side of the SO2 or whatever the substance is that we're working with. So we write in here opposite. And then to figure the shift, we go back to the equation and we look and we see where SO2 is. See, it's right here on the left side. So what is opposite of left? That's right, of course. That's correct. The right side, okay? The right side is opposite to the left side. And that's the way LeChat is going to offset what we did. We added this, he takes it away. And he takes it away by putting this together with this to make this. And that takes care of our first problem. Let's watch the logic happen again. In number 2, SO3, it says, is present. The SO3 present is liquefied and removed from the system. So we, as a stress, we take away the SO3. Now, what does LeChat want to do? He wants to add SO3. And whenever LeChat doesn't add whatever he's adding, he goes to the side that it's on. So we go to the same. It's either opposite or same every time. In this case, it's the same. So now we have to look and see. He wants to add more SO3, so we have to go to the same side that SO3 is on. Let's look and see what that is. SO3, it's on the right. So the shift is on the right. or to the right. And that takes care of letter B. Let's go to C and read that one. A very efficient catalyst. Okay, so we use a catalyst. Catalysts, if you wrote down the first screen that I showed you, you'll know that catalysts do not affect equilibrium. So whether it's an efficient catalyst or just a bummer little guy that hardly does anything, it will have no effect on the equilibrium. So there is no stress. And LeChat, because there is no stress, he has no reaction. And there is no shift. And those guys are really easy. Okay, let's go on to 35, and let's see what's happening there. Let's go back and look at number 35 in here. And number 35 is this question right here. And we will pause the recording for just a moment and resume.